Hi guys. Today this video is going to cover compound interest. We've been talking about exponential functions, and one of the main applications of exponential functions is compound interest. So compound interest is when you put money into a bank and they give you interest on that money. And so that's what we're going to be talking about is, okay, what happens if they do compounding annually, what happens if they compound monthly, etc. So let's take a second to read the problem. If you read through this problem here, we're going to kind of dissect it and see what's going on. You have $800 you're putting into a bank. The bank pays a rate of 3% per year. Remember that 3% as a decimal is 0.03, so that's something to keep in mind. And they're putting all the interest back into the bank so they can earn even more money. And that's what is compounding. Every bank gives you money to put your money into it. They're like paying you to borrow your money for that time, and they will then just put that into the bank. Okay, how do we do that? If we have $800 and we're earning 3% per year, well, one way is to do it kind of the long way on our calculator. So I'm going to show you how to do that. So if you have $800 and you multiply that by 0.03, because that's 3%, that means you're getting $24. That means that we're going to add that to the original amount and we're going to get $824. So in my table, I can put $824 in the next box. And then I can keep going. I can multiply that by 0.03 and put it in, multiply that by 0.03 and put it in, and so forth and so on. But that's kind of the long way because we've been learning about how to do these with equations. And so let's answer part B. What function are you using? Well, remember that our formula that we have is A equals P times 1 plus R to the T power. And we started to learn that last time. And so our formula is going to be A equals P is how much we start with, and 1 plus our rate is 0.03, and we can use a T for the time. That in this case is how many years. Okay, so that's one way to do it. So if we go back to our calculator, we can put that into our y equals and then just use the table. One thing about the table I have set up here, notice that there is a break between 3 and 6 and 6 and 9. In other words, if you just start writing down numbers, you're going to write them down wrong. Okay, let's go back to the calculator and put that into the y equals button. So I'm going to go to y equals 800 times 1.03 to the x power. And now I'm going to hit enter. Now I'm going to go to my table button, which is over here. So I'm going to go to second table, and I can scroll down to wherever I need to go to. So we start with $800. We get to $824. We already knew that. Then we get to $848.72, $874.18, and so forth. Now the reason I'm in this column is I wanted to show you. Notice that down here at the bottom, it has all of the digits. So this column was only wide enough to get 5 digits, which is fine for us because we have hundreds of dollars and we have cents. And of course we want to, round off to the cents. But it will show you all of them if you need that for some other reason. So if I go down to the next one, 900.41, it's actually 900.407. So if anytime you needed those extra decimals, just go over to that Y column and click on it there, and it'll show you all the decimals. Okay, so I'm going to go down. We were looking for 0, 1, 2, 3, which are these, and then we were going down to 6, which is $955.24, and then we went down to 9, which is $1,043, and this is what I'm talking about. So like it cuts it off at 8, but down here, because I'm on the Y cell, it has 8.818, so that would be 82 cents. So we write that into our paper, we're going to write down 82 cents. Okay, let's go back to that paper and fill in those numbers. Okay, hopefully you were doing that on your own calculator as well, but these are the numbers that we got off of the table from the calculator. Now the question is, how long until the money doubles? Well, we start out with $800, we need to get up to $1,600. We're not there yet. And this is something that it showed up on last week's assignments also, and people were confused on how to do that. We will learn how to do that mathematically, but as for now, we just have to go back to our calculator. And so if I go back to my calculator, I'm looking for when will it get to $1,600, and I'm just going to have to keep going down. And if I get tired of doing this, I can maybe do a change table, which I can show you in just a second. But here we are. In between years 23 and 24, we can see that's when it gets between, 1,600 is going to be right in here between years 23 and 24. So I'm going to go back to my paper and enter that. So that's going to take 23 to 24 years to double. Now, again, we will learn next week how to actually calculate that more precisely, but for now we're just using our table. Okay, the next question, what if the bank is paying 3% annually, but they are compounding monthly? So that fee, that percentage that they're paying you, instead of giving it to you every year, what if they're giving it to you every month instead? Well, we need to think about a couple of things. First of all, we've got 3% annually, and so we know that 3% is 0.03. We just talked about that a second ago. But if they're compounding monthly, they're not giving you 3% every month. They're giving you 3% every year. So in other words, we need to take 0.03 and divide that by 12. And so if I go to my calculator and I divide that by 12, and why am I dividing by 12? Because it's monthly. There's 12 months in a year. So if I take this and divide by 12, I get 0.0025. And that is 0.25% monthly. So they're giving you 3% annually, but 0.25% monthly. Okay, what is that going to do to the function? What that's going to do is I'm going to put y equals, I still start out with $800, but this time I'm going to get 1.0025, that was my percent, and I'm going to put an M up here just to remind myself that that's every month, not every year. So now I'm going to go back to my calculator and I'm going to put this into my y equals button. So I have 800 times 1.0025 to the M, the month. I'm just going to use X on my calculator. So now when I go back to my table, I'm going to hit second table, and I get this table. Oh, I'm way off, right? I want to go back to 1. I can do that. The easiest way probably to do that is up here there's a table set button. So if I go to second table set, and I want to start at 0 and I want to count by ones. So I've just done that. So now I need to go back to my table. So second table. And once again on this table on the paper, I did skip some months. So 0 is where we start with $800. First month we have $802. The third month we have $806.02. Now 1 year, that means I'm going to go to 12 months. So I'm here at $824.33. And then 3 years, that would be 36 months. I could arrow down or I can go to my plus button. I'm going to move over here. I'm going to go to my plus button and I'm going to change my 20s because you see that just means I'm going to jump 20 down. So now I'm going to get to 32. Here we are, 32. And now I'm going to go back and go to change in table again, change it just to 1. And that was just kind of a quick way to jump down. I could have gone to table setup again and done it that way. But 36 months would be 3 years. I have $875.42, or excuse me, 24 cents. And again, if you need all of the digits are down here. Let's write that stuff down on our paper. Okay, so here are our numbers from before, from our calculator. I will say, I forgot to do this, but I wanted you to think about, will compounding monthly give you more money than it did to compound annually? And if it did, how much more? Well, let's just look at our table up above and compare. Okay, up here for 3 years, we had $874.18. Here, after 3 years, we had $875.24. We got about an extra $1.06 out of this, which really isn't a whole lot of money. I mean, if you start with $800, you're talking about $1 extra. That's not going to change a whole lot, in terms of your financial future. So one thing to notice is when we change from compounding annually to compounding monthly, some people think that's going to take their money and multiply it times 12. Well, it doesn't. It doesn't multiply your money times 12. It just gives you a little bit more by 12. And so we get that a little bit more each month, but really not a whole heck of a lot. Another $1 in terms of this $800. Not a lot. Okay, What about if we do more than this? So this was every month. And when we did it by the month, we put an M here to remind us that that was a month. And we changed our rate. That is, we divided the number that we had of the rate divided by the months. So now we have a new formula. It's the same formula, it's just a little bit more specific. So take a minute to copy this down, but I'm going to kind of talk through it. The A is the same as it was before, the end amount. P, did you know that P stands for principal? That's a word that's like kind of a banking word, kind of a financial word. It just means how much did you start with. Now, instead of just an R, we have R divided by how many times it's compounded. So that was when we, up here at this example, we took our rate, our 3% rate, and we divided it by 12. So that's what's going on here. We took the rate divided by how many times it's compounded. And then the NT is N times T. It's the total number of compounding periods. So again, up here I put an M to remind myself it was the months. So if it was 2 years later, it would be 24 months. Or like in this case, it was 3 years later, that was 36 months, and we had to scroll down on our calculator to get down to 36. Okay, so pretty much the same formula, but a little bit more specific. There's one more example, one more table that I want to do on this. So let's turn the page and go to our next table. Okay, here's what I want to do in this table. I want to take a look at a little bit more of a hypothetical, okay, coming up with kind of a general pattern. Because we had this concept, like I said a second ago, where, okay, we did it monthly, that only gave us an extra $1 out of $800. That wasn't a huge jump. Well, what happens then if we, this is being not invested at all. We do it annually, that means we do it once, twice a year, 3 times a year, monthly. What if we do it every week? What if we do it every day? What if we do it like every, I don't know, if that's 3 times a day, 1,000 times per year, or 10,000 times per year, or 100,000 times? What's going to happen in that case? So let's take a look at this. Remember our function from the other side. Okay, let's use this function along with that it's paying 100% interest. Remember, for percent, we move it over 2 places. So this is a 1.00 for percent. Let's see what that function would be. It's going to start with A equals. We start with $1. Our inside of our parentheses is always 1 plus the rate divided by the number of terms. So I have the different n's here. Our rate is 1. Our number of terms is n. And then on the outside, it's n times t, but we're talking about 1 year. Exactly 1 year. So it's going to be 1 times n. Well, I can call it 1n, or I can just call it n, right? So that's the same thing. Okay, now we're ready to go to our calculator and put this into our calculator. Okay, I'm going to put in 1 times 1 plus, and then I have, I'm going to maybe put a new parentheses here. 1 divided by x, and then I'm going to close the parentheses there. I'm going to close the parentheses for the whole thing and put that to the x power. Okay, you could have put a fraction here, but I just think it's just as easy to do it this way. But you do need those parentheses. Just, I never trust my calculator without the parentheses. Okay, so if I go to my table button, in the 0 column they have error. That basically means you didn't invest it at all. And the reason it's an error in this is because we have a fraction of 1 over x, and so that would give us an error. But basically on our paper, if you don't invest it at all, you still have that dollar. Okay, but after 1 year, if this was 100% interest, that means you double your money. So after 1 year, we have $2. But if we start, and that was if they compound annually. If we start looking at what if they do it twice a year? Well, you get another 25 cents on top of that. We've talked about it goes up, just doesn't go up a whole lot. Okay, what if they do it 3 times a year? 3 times a year would be $2.37. Again, it goes up, just not a lot, but it does go up. What if they do it every month? So let's skip down to the 12, and I'm just going to arrow down to 12. If it's 12 times a year, that's once a month, it is 2.613. I'm going to go to my table setup and go to 52. So now I'm going to go back to my table. After 52, that means once a week. Now I'm actually getting, it seems like a little bit more money, $2.69, which isn't bad for a $2 investment, right? Okay, so weekly is going up to $2.69. Here's why I did the counting by 300s is I want to go to the 365, which in this case is here. I'm going to go back to changing the table. So my plus button, and I'm going to change it by ones instead. Look at what's happening. First of all, the 365, that means every day, and it's gone up to $2.71. But look at this. All of these are the same, the exact same. Now, they're not the exact same, are they? Because if I scroll down, my digits are changing by just a little bit every time. But it's basically 2.714 every time, right? Maybe round it up to 2.715. Okay, what happens if I go into the 1,000 range? So I'm going to, okay, 1,000 is 2.716. 10,000 is also here, 2.718. But again, notice how they're just barely changing. They were changing a lot, it seemed like in the beginning, like 25 cents on top of, every year was a lot. But now we're talking about doing it every 10,000 times and it's barely changing at all. The rate is actually slowing down. And if I go to 100,000, okay, here's my 10,000, 2.718. This one is 110. I'm not even going to bother to go back and change my calculator because look, they're all 2.718. If I get down to the next level, this is 1 million, still 2.718. Seems like it's not going to change a whole lot from 2.718. That's kind of where we're at. All right, let's go go back to our paper and write this stuff down on paper. Okay, these are the numbers that we got on our calculator. Notice it was going up by a lot at the beginning. It went up by 25, and then it went up by 12, and then it went up by, and that was from 1 to 2 to 3, but then we started changing increments. But my point is it went up by a lot in the beginning, and it's lessening and lessening every time. And so over here in this column, I went ahead and put some more digits. I know it's money, so we would normally round it to cents, but I wanted to see what the pattern was going on. So the maximum number that the balance can reach in 1 year, what do you think that maximum number is? Well, it's $2 and 70, we'll call it 72, or maybe I'll call it 2.718. 2.718. That's the maximum that the balance can ever reach. That was after 100,000 changes per year. That's a lot. Okay, but that is the end of our video for today.